Hello, welcome to this new tutorial. This is Hussein bin Fayaz. Today we are going to look into a simple end-to-end MLOps tutorial using PyCaret. PyCaret is Python's open source low-code machine learning library that automates the machine learning workflows. So we're going to look at a simple example. I'm going to zoom up so that you can follow along. This is the Google Colab notebook which I have opened up. Let me write the capture command. The reason for writing this magic command is because I'm going to install the libraries here and I don't want the installation logs. So let's begin with pip install PyCaret, and I want one more library here which is called Gradio. So Gradio is used for building UI based application using Python, and it is merged into PyCaret so we can build those applications in a very simple way. So let's run this cell. Let's wait for the installation to be completed. Now, comparing with other open source machine learning libraries, PyCaret is an alternate low-code library that can be used to replace like hundreds of lines of code with a few lines. This makes the experimentation process fast and efficient. PyCaret is essentially a Python wrapper around several other machine learning libraries and frameworks such as scikit-learn, XGBoost, LightGBM, and a few more. Now we have written two commands. These will install the required packages alongside all the dependencies. You can follow this along inside a Google Colab or on the local Jupyter notebook. While it's installing, let me write the next code which is required for our current example. So what I'm going to do is I'll simply write PyCaret dot datasets import. So I'm going to use the built-in dataset which is provided inside PyCaret. Let's run this cell. So it shows a preview of our dataset. The goal here is to predict if the patient has diabetes or not, and this here, if you can see, class variable is the target column which we need to predict. So it's a simple classification problem. Now let's just try to initialize the setup by giving two parameters. So first import from PyCaret dot classification import asterisk, and then I'll use the setup function. I'll pass the data, and now I need to highlight which is my target column, and that is class variable. So we use target parameter for it. Let's run this cell. Okay, now it shows that it has done the pre-processing, and these are all the other parameters that you can pass inside your setup. Now the important part, you need to know that there are numerous classification models available in machine learning, and running or training each one of them in a sequential manner is a tedious task. So PyCaret has a built-in function which is called compare models. This function highlights the highest accurate model among all the available models. So let's say I write this best equals compare underscore models. What it's going to do is it's going to take the data set that we have already provided, train all the available classification algorithm, and then return the best one. So let's just run it. It's going to take a few seconds because the data set is not too big. You can see that it has started with logistic regression and proceeding with KNN, naive Bayes, and at every iteration it re-ranks all the models here in terms of their performance. Let's wait. And it's done. So you can see the highlighted cells as well. The best performing model was logistic regression in this case. Now next thing that we can do is we can evaluate the model. So evaluate underscore model, and we can pass the best, which is the best model logistic regression in our case. So this is what our pipeline looks like. Raw data, it has used simple imputer, it has cleaned some column names and applied logistic regression. So let's say if you want to see confusion metrics, you can click here, and this is the confusion metrics here. Let's say you want to see the feature selection or probably feature importance. It's gonna take some time. See, this is the feature importance. This diabetes pedigree function is the most important one in our case. So you can visualize a lot of different things using these buttons. Now come to the most interesting part, because of which you have probably landed on this video, and that is the MLOps part. How we serve this model. We have trained a model, how do we serve it? So there's a simple function which is called create app, and if I pass best, which is essentially my best trained model, and I run it, so you can see that it has provided me a link. It has essentially created a visual application inside Gradio and deployed it on a live link. Now these are all the parameters on which my model is trained. So let's say I fill it up. Number of times pregnant 2, plasma glucose let's say 130, diastolic blood pressure 80, uh, skin fold thickness let's say 45, serum insulin 50, I want to say 23.1, diabetes pedigree function 0.4, age is 30. These are just random values. You can try out with the different ones. So output is not really clean, but if you look here, this says prediction label equals 0, which means the patient with these properties does not have diabetes. Okay, so this is our prediction. Now this live link will be expired after 72 hours. The next thing that you can do, and it is kind of a task for you at the end of this tutorial, which is deploy underscore models. This is another function which is provided inside PyCaret, and here you can basically deploy this model to different cloud providers like AWS, Azure, GCP by mentioning your relevant credentials. So look in the documentation about this particular function and see if you can directly deploy the model into the cloud. So that's what you can try at home. And this whole purpose of showcasing your model in form of application is very helpful for the beginners who wants to build a portfolio and they're applying for the jobs. So for the portfolio building purposes, this will come in very handy. So follow along, explore the deploy model function as well, and let me know if it helped you out. Thank you so much.